Good morning, class. Okay. Today we're going to learn about chapter 4, force and motion. Our main topic will be Newton's second law and friction. The principle is a static block will be start moving depends on two criteria, will be the inclined plane angle and the coefficient of static friction. The block will be expected to move when the angle is large. Oppositely, when the coefficient of static friction is lower.
Hi, so based on this experiment, we found that block starts moving at 0.4 coefficient of static friction. On the on the table, we plot it here, and the last value of coefficient of static friction when the block is still static is 0.577. Based on the formula given, we use this. Mass gravity sin theta equal to US mass gravity cos sin theta equal 0. So if we look from the formula, when we do calculation, we got the answer is 0.03. So that is first one. For second, the first value of coefficient of static friction is 0.576. That is when the block starts moving. Using the formula, mg sin theta minus US mg cos theta equals 0. So the answer we got after the calculation is 0.12. Bye.
Okay, next I will teach you how to use this application to find static and kinetic. First thing first, you must follow the initial velocity and gravity, and you put here such as intervelocity as 0 ms, you put in 0 ms. Okay, next, if the block are not moving, you must stick here X, and if the block are moving, you must put the yes at the block. Okay, then the last value of angle when the block still static angle, we put some 32.7. Then we use this formula to find apply force, French force, and empty sign. This is for the example for the question. And then the first value, angle when the block is moving angle, we put 22.8 on the Michael, for example lah. And we use this formula to get the block to get an angle for the block when it's moving.
Hello, I want to explain about this question based on task number 1. Refer to the task. If the mass of the object reduces, will we have a different US? Let's prove it. Based on the formula given, the original weight is 10 kilo. When we reduce the weight to 9 kilo, let's try to using the formula. The formula is like this. And M is 9, G is 9.8, sin theta is 0.5 minus US. The number we want to find, and then M9, G gravity 7.8, and cos theta is 0.866. Okay. And the answer that we find using the formula is 0.85. So we can prove that we will have the different US from the task 1. Thank you.
Good morning class. Today we're gonna do discussion task 2. What you're gonna find out is you're gonna see a different angle. Okay. If change the material block and plan from wood to steel, do you expect a higher angle before the block start moving? The formula we're gonna use is and now we're gonna change the formula to the wood and steel kinetic and static numbers. So now how do we do it? The first thing is we're gonna change the first, and then after that the next step is we're gonna do the same thing, which is we're gonna calculate and now we're gonna change the G2 and we're gonna change this to 0 point because you're gonna see two wood and steel, so we're gonna take the static from this point. After that and then the answer will be that's all today.
The conclusion for this experiment. The second part of the experiment involved exploring Newton's second law, which states that the net force acting upon an object is equal to the object's mass times its acceleration. Coefficient of static friction is a factor moving the block. For the case in task 1, the critical value coefficient of static friction when the block is moving is angle is a factor moving the block as well. The two equations could then be manipulated in order to condense them into one uniform equation that relate the two systems to each other. The third part of this experiment involved determining a relationship between the net force acting upon an object and its acceleration. This relationship was studied using a simulation program on the internet. For the first part, friction force was neglected and the relationship between the applied force and the object's acceleration was studied. For the second part, frictional force was included and the net force was graphed. The slope of the curve in each graph reinforces Newton's second law by showing that more forces is needed to accelerate an object of larger mass. That's for the conclusion. Thank you.